tornadoes, right. They're like way more than just those movie scenes, you know?
For sure.
We're going to dig into this Wikipedia article today and
Good.
really like break down some of the surprising stuff about these powerful things.
Yeah, it's amazing. Like, even if you think you know a bit about tornadoes, there's always so much more to discover.
Right. So we all have like that basic picture, violently rotating air column connected to the ground and a big old storm cloud.
Yeah,
But then it gets wild when you realize those tornadoes, they don't always look like that classic funnel.
absolutely. Some are totally hidden by rain or dust, which makes them crazy dangerous because you can't spot them easily.
Yeah.
That's why we rely so much on radar and warnings.
Yeah, stealthy forces of nature.
Totally.
Speaking of misconceptions, I used to think cyclone and tornado were the same thing, but I've learned.
Oh, yeah. It's a really common mistake.
So what's the deal there?
Well, in meteorology, cyclone is way broader.
Yeah.
Think like a huge low-pressure system, winds spiraling in. Tornadoes can form within them, but they're just one piece of that bigger picture.
So scale matters. Like tornadoes, we've got everything from those massive wedges to the skinny rope ones, right?
Exactly. And the variety isn't just in shape, it's color too. We think gray, black.
Right, right.
But they can be colored by whatever they pick up. Red tornado in Oklahoma, probably churning up that iron-rich soil they've got there.
Whoa, that'd make for an intense photo op.
For sure.
I've also heard tornadoes aren't always loud, like, that freight train sound. Is that true?
It's true. Some are eerily silent, especially at first. You can't rely on just hearing them for warning.
Makes sense. So this whole tornado supercell connection, what's the deal there? We hear those terms together all the time.
Right, so those super intense tornadoes, the EF3s, EF4s, EF5s, those usually come from supercells.
Okay.
Which are these crazy, powerful thunderstorms with a rotating updraft called a mesocyclone.
Mesocyclone. Remind me.
Basically, it's like a rotating column of air inside the storm. And that rotation gets concentrated, stretched down, and boom, tornado.
So it's like being sculpted from the sky down.
Exactly. It's pretty amazing to think about.
But you're saying not every tornado needs this whole supercell thing to get going.
You got it. There are land spouts and water spouts. They're like the little cousins, less intense, still violently rotating air, but they form without that mesocyclone setup. Land spouts, for instance, you see those more in flat areas, and they tend to be weaker than the supercell ones.
So whether it's a supercell behemoth or a more localized land spout, once a tornado is going, does it have a life cycle? It's not just chaos.
Right. There's a pattern. Starts with formation, that funnel cloud drops down, touches the ground, then maturity, that's its peak power, most damage happens there, and finally, dissipation kind of stretches out like a rope and then fades away.
So even when it's dying, still super dangerous.
100%. It's like, think of a spinning top, right? It's slowing down, but it's still spinning super fast and can still knock stuff over.
Great point. Okay, let's bust some myths. We've all heard them. Like opening windows during a tornado. Good or bad?
Ooh, bad idea. The thinking is it equalizes pressure, but honestly, that pressure change is so fast, opening windows does almost nothing. And it might even make things worse because now debris can fly in.
And what about hiding under overpasses? That's a big no-no, right?
Huge no-no.
Yeah.
Seems like a good idea, right? Find some cover.
Yeah.
But those spaces can actually make the wind stronger, like a wind tunnel. Plus, you're more at risk from flying debris.
Yikes. Not where you want to be. Okay, so we've talked about the enhanced Vegeta scale, the EF scale. Break that down for us. How do we actually rate a tornado's intensity?
So the EF scale, it's all about the damage caused, not just wind speed, but the actual impact.
Right.
EF0, maybe some trees down, not much for sturdier structures. EF5, we're talking ripping buildings off foundations, even skyscrapers get messed up.
That's just wild. And they determine this after the tornado's gone by, looking at the aftermath.
Exactly. They look for clues in the damage, like how badly a house is hit, if a car got tossed around. That helps them estimate the wind speeds involved.
Forensic meteorology. I like it. Now, we hear tornado, we think Tornado Alley, but that's not the only place, obviously.
Nope, not at all. Tornado Alley, that's like central U.S., right? Their geography's primed for it.
Right.
Warm, moist air from the Gulf. Then you got that dry air from the Rockies.
Yeah.
Perfect recipe for supercells.
Nature's just like, let's make a tornado.
Pretty much.
But then our article here mentioned Bangladesh. Lots of tornadoes there too, which I thought was surprising.
Yeah, it's interesting. They're in a delta, prone to thunderstorms anyway.
Right, right.
Plus, they're near the Himalayas, which can mess with wind patterns. So really complex.
Kind of all connected, right? Like this big global system. And speaking of that, what are some of the most interesting things scientists are looking at when it comes to tornadoes?
Well, one that I think is super cool is mobile Doppler radar. They call it Doppler on wheels sometimes.
Doppler on wheels. That's got to be
Well,
the coolest name ever.
right. But it's serious tech. They can get way closer to tornadoes than before. Measure those insane wind speeds, even get a glimpse inside the tornado.
Wait, inside, I always figured it was just like solid chaos in there.
That's what we thought. But turns out, many tornadoes, especially the strong ones, they might have a calm center.
Whoa, like the eye of a hurricane.
Exactly. Makes them even more awe-inspiring, and maybe a little creepy too. Still so much we don't know about what goes on in there.
So, with all this research, these cool tools, are we getting any closer to actually predicting tornadoes? Like, really predicting them?
That's the million-dollar question, right?
Yeah.
We've gotten way better at forecasting the conditions that could spawn tornadoes.
Right.
But saying exactly when and where one will touch down, that's still a huge challenge.
So we can be like, heads up, conditions are right,
Nah.
but not much more specific than that.
Yeah. That's the next frontier, for sure. Researchers are building better models, trying to simulate how tornadoes form. Hopefully one day we'll have those precise predictions.
I mean, can you imagine being able to say, okay, not just good chances of tornadoes today, but there's going to be one here at this time?
Right.
Total game changer.
Oh, absolutely. People could get to real safety, so many lives saved. It'd be incredible.
It really would. So while we're waiting on that, what are some of the other big mysteries about tornadoes scientists are still trying to figure out?
Well, one of the big ones is that initial spark, like what actually triggers a tornado to form in the first place.
Okay.
We know the recipe, right? Unstable air, wind shear. That's where the wind changes speed and direction as you go higher. You need moisture. But what flips the switch from those conditions to a full-blown tornado?
So we've got the ingredients, but not the aha moment.
Exactly. And then there's intensity. Why do some stay small, weak, while others go full beast mode, causing all that destruction?
And why do some last for minutes, others stay on the ground for miles, right?
Yep. Still working on those.
Right.
Researchers are looking at everything. The role of downdrafts, how temperature and moisture play a role.
Wow, it's kind of amazing how much we don't know about something that's so powerful.
Right. Humbling, but also super cool to think about.
Totally. So as we learn more, hopefully we get better at predicting, preparing, lessening the impact, right?
Absolutely. That's the goal.
Well, this has been awesome. I feel like we've gone from zero to like tornado experts just by diving into this Wikipedia article.
Right. It's amazing what you can learn when you dig a little deeper.
Totally. And for everyone listening, stay curious about the world around you. Knowledge is power, especially when it comes to staying safe.